Good morning, good afternoon, good evening, depending on when and where you're viewing this webinar from. Just to introduce myself again, my name is Dave Eckroat. I am the director for IDEA StatiCa US. And today we have a nice user story with Colten from Flint Engineering, looking at some metal building connections. So go ahead, next slide. So just again, as a reminder, I'm sure most people have used GoToWebinar previously, but in the control panel, there's a question pane. So if you have any questions for us, feel free to type them in there and we can get to those at the end of the presentation. We'll do a little Q&A. So just looking at the agenda for the session, first we'll kind of do an introduction of Colten and his company, Flint. We'll talk a little bit about this specific project that we're going to be looking at today with some metal building connections. Then Andrea will jump into the software and kind of show a couple of the two connections from that project in IDEA. Then we'll do a summary and then a quick Q&A. So with that, I think we're all good. So Colten, sorry. Why don't you just give a quick introduction of yourself and your company?
Yeah, thanks, Dave. Appreciate it. Thanks to you guys for having me. So yeah, Flint Engineering, we are a newer structural engineering firm as of right now. We were birthed out of an opportunity from some entrepreneurs that also own a steel fabrication and a steel erection company. And so we are heavily linked into the construction side of the world. We get to play a little bit of both devil's advocate on the design and on the construction now. But personal experience, I have an Archie degree, went out to Portland for a little bit, did some high seismic design, and then Kansas City for, I actually worked as an in-house structural in an architectural firm. So I got to see the difficulties and challenge of an architect. So as a structural engineer, normally an architect is a four-letter word, but now I have a bit more grace and compassion for what they have to go through with their clients. And then moved closer to Wichita, and went heavy on the industrial side, gas and oil, refinery, fertilizer, all that good stuff. So recently started, so I'm the principal engineer, founding engineer here at Flint Engineering, and now we've got a pretty small team, as well as some contract remote workers that help us out from time to time. So we're a pretty lean, mean fighting machine, and it's been fun to have the opportunity to try to grow this thing.
Cool. Yeah, that's it's interesting because I spent some time at an AE firm, and it's definitely a great experience to kind of understand the whole design side of things. I think you kind of working directly with a fabricator probably helps you on the construction side as well. So that's very cool. So I guess obviously kind of more on the industrial type side. I guess what types of projects are you working on currently?
Yeah, we kind of range and hit the gamut, and especially in a growth season, we're trying to be strategic, but also having the startup model, there's funds available to say no to the things that aren't a good fit. And so I think we're fortunate to be able to have that opportunity to say, I could probably make this work, but it's just not a good focus for Flint right now. So, but some of the things we're working on, there's a metal building remodel that's an absolute disaster it's 4 different metal buildings that were all scabbed together. We're tearing stuff out. We're putting in new stiffeners and everything, and it's a lot of fun, but it's a lot of work. And so that's where point clouds get involved, heavy coordination on the construction, sourcing the material through the steel fabricator and getting it on site by a certain time. All that stuff has been it's fun to do. It's in the moment, and the deliverables, you're always staying up late pulling those nights, but yeah, it's worth it on that side of it. We've got there was a facility that needed access to 6 different tanks, so we did a brand new steel structure, ladder, and then each one had a fall arrest system attached to it. And so we were, you get involved in that kind of stuff, and it's the loads are fun, get real fun real fast. So
sure,
yeah, those are kind of the two big ones that we just wrapped up.
Okay, good. So I have to ask the question: you prefer working on existing projects or new construction?
It depends, mostly existing. Yeah, I think those are the ones where if you put your business hat on, there's a lot more leverage for your services. And so more work means more fee, means more time. And then you also, with the way that we're set up, people see the value in some of the coordination that we have the opportunity to do. So we could bring some of the steel detailing up front on the design side for heavy coordination and getting accurate pricing if they need to do that. So we're definitely trying to leverage the design build side of the world more so than your traditional design bid build. And it's been fun to see some of that. And we'll talk about it more, but yeah, getting into the AR coordination, AR experiences for our clients, as well as some other tech. It's been interesting to get to see kind of how it all works together and what people actually value and what they don't. And, yeah.
Awesome. Okay. Anything else you wanted to mention about your company? I think that was pretty comprehensive.
Yeah, I mean, we're a full service structural engineering firm. I guess it's probably best to say we don't do concrete, buildings. We'll do foundations and retaining walls, but we don't do that. We don't do multifamily facilities or structures, light frame. We don't do any of that, and that's just because we don't have a team that's experienced in it. And so everything outside of that we're doing, and we're heavily engaged and involved with contractors and the design build side of the world. And some of the fun stuff that we do with our team is, we have a headset, so that bottom right picture is it's a snip from a video, but the client there in the bottom right corner, he put the headset on. We had modeled the existing building. He put in, there's our overhead cranes, and then there were some jib cranes on top of it. So he got to walk around his remodel before he spent any money on construction. And we, in the video, he's like, "Oh my gosh, this is amazing. What is going?" And it's just that wow factor for him. And that's one of the powerful things that I think I'm excited to see more of in the construction industry and on the design side, because most people aren't trained to read our documents. Owners rarely have any experience in that. And so whenever you can get them to buy off on your design from a 3D perspective, especially in the space, this 3D models are great, but then to walk around the facility to see what's going to be changed, what's going to be new, it's a complete game changer for them. And so you get that early buy-in where there's no questions, and if there are questions, they're very minimal at that. So yeah, and we also have a pretty robust, one of the unique things, we do a hybrid part-time position. So that's one of the things that has helped us stay affordable, pretty lean. We'll give people access to all of the tips and tools that they need, but they're kind of part-time and as needed basis. And so we've had some really good success with some great engineers and drafters on that side of it. But yeah, we're just getting after it. And if you scan that QR code, it's my contact info if anybody wants to reach out to me, has questions. Probably one of the things that is more unique about me is I have a podcast for engineering, specifically structural engineering. So been able to have fun with that, and you get to know people, you get to know how little you actually know about certain topics, kind of like you guys when you do presentations, you kind of have to know nuts and bolts of it all, and then people ask you questions and you got to know the answers to them, or at least direct them in the right way. So yeah, that's probably enough about me at this point. So
all right, I do have actually a couple more questions about your experience when using IDEA StatiCa. So you and your team have used the software for a bit less than 6 months. I was just wondering, how was the learning curve, and if you have any feedback on this, that'd be great.
Yeah, overall, with any new software, I think we as engineers are slow to change because of the deadlines and the pressures we have to perform and to know that our designs are safe. And so anytime you add a new software to it, everyone is reluctant to change, and it's mostly for a good thing. It is time intensive to learn, at least for me, right? Going through all of your material, understanding the thought process behind how you're doing things, because it is a little different than just a true FEA analysis. And so that, I would say took a little bit of upfront investment, and now we're seeing the fruit from that, just from the ways that we're able to economize and serve our clients better in some specialty items, specialty connections, niche requirements for different things. So yeah, I'd say overall, it's been worth the investment for us. We do delegated design, connection design, and so that's part of that serves that purpose. And so I think if you're in the right clientele, you have the right project types, it's definitely worth it.
Yeah, that's true, definitely. You were talking about all the content that we have on the website, but I think also what you did was smart of So you started by getting a training session that I think only your colleague got to attend. You've been in touch a lot with Andrea for technical support related questions. Any testimonial, any word on this, on how these ways for you and your team to learn the software have been?
I think the training was helpful for the engineer that took that, and he was able to kind of come up online a lot quicker than I was when I was brute forcing my way through the material. And then the support, I will say, the one thing that has been great is with Andrea to be able to just send her an email and be like, hey, this is not working the way I know it's supposed to. What is wrong? And oftentimes it's same day turnaround. She'll get me something. And if I send her the model, she'll do it for me. And then, maybe I shouldn't, advertise that as a service for you guys, but that's been my experience. Is she's been able to turn stuff around for me and say, oh yeah, just do this, this, and this, and you're done. And I've done it for you, so go ahead and take the model back. And so that I will say is A+ gold star on customer service.
Yeah, it's not the first time we hear that about Andrea and Johan as well, our other product engineer. All right, thank you.
All right, so that's my turn. Now let's jump into the project. All right. Can you give us a quick overview of this project and some highlights that you would like to share before we jump into the live demonstration?
Yeah, this project was, we're getting more into metal buildings, but we're kind of dipping. We dipped our toe in it. This was a kind of a hybrid metal building project for us, where we were in charge of the foundations, and that's pretty standard. But the steel fabricator or the metal building supplier wanted us to design the main frames. They didn't want us to touch any of the light gauge material. We're just utilizing the main framing system. So that's where we got into this facility, and then it was kind of a weird approach of, we need to make sure it's stable and sound, but we're coordinating what they're doing with their framing at the same time. And I would say the unique part of this project for this client, the supplier, is they wanted all welded connections, and that just fit their production and the way that they did things. And so there were no bolts essentially on any of the frame. And what we realized with the kind of testing out IDEA StatiCa with it was, we could be very efficient with our design, and we could really get down to the nuts and bolts of the welds, where the stiffeners are, and how it was all going to work together. Yeah, I believe at this point you guys had the partial joint penetration weld when we were doing this design, but I think that would be another way where we could have refined some of this design as well.
Yeah, that's right. I saw some of the welds in that model that you shared with us, and I was like, maybe he needed that PGP weld. But yeah, I can discuss that later in the model. All right, so I saw that you were using ASD, right? Is that correct?
Yes.
ASD methodology. All right, just for the presentation. So can you just quickly go through how IDEA StatiCa helped you to achieve success on this project? I believe we'll ask you more about that, but maybe if you can tell us more about that.
Yeah, I think specifically with the software, we have conventional standard ways of analyzing moment frames, and those are, for lack of a better term, you're not really, you save time by being conservative, and so that is kind of true of any design that you do. You can save time if you assume and just add more material to it or more weld. So IDEA StatiCa didn't save us time, I'll put it that way, but it saved our client time and money, and that was what was important. So it allowed us to be very detailed and get down to sharpen our pencil per se in how we wanted to do this. And so we were able to iterate a lot of different options for them. We just had a young engineer kind of throw spaghetti at the wall per se. We sent them some different designs, looked at what they wanted out of it, what was most efficient for them, and then they selected one, and away we went with the design.
All right, perfect. Thank you for sharing that all that information. That's very helpful. And yeah, so I have here some details about the connections that I'll present today. So if you can bear with me just while I'm presenting this, just in case I have some questions about the details and how we represented that on IDEA StatiCa, right? All right, so I'll start with the live demonstration. I have two connections to present today. One is one of the reach beam connections, and the second is the moment frame connection. So let's go to these details. So well, this is like the general reach beam connection for, it's applicable for those reach beam joints that you're looking here, all right? But then in this case, Colten represented the bracing rods passing through the beam with some openings on the beams. So I'll start this connection from scratch, right? If you haven't used the software, I'll show you how to set up the model, all right? So let me open IDEA StatiCa here, IDEA StatiCa connection. And this is the first screen you will see whenever you're starting a new model, right? So you here in this menu, you have like an option to pick and choose templates. So we have different classes, then you can scroll down and you'll see more templates to start with. And then for this case, I'll use the beam to beam joint or geometry. And then the most similar connection that we have here is this one, all right? So you can set up the default parameters. Every time you add a new member or a new material, that will be still grade A and N2, but everything can be modified later, all right? So you can, well, let me click over Create Project here. And you will see that we'll add the model. Well, you'll see the model already constructed there. And then you can start tweaking this model, okay? So then if we look at this view, you can see that it's a bolted connection, but everything will be modified. Let's start changing the cross section. So in this case, B1 is 12 by 30. That's the default value. So we'll change that for a 16 by 31. So to change the cross section, you can go to the plus icon, and then you are adding a new cross section into this model, right? So I go to my favorites, and then I type 16 by 31. So you can see this section there, and then I click over that one, okay. And then I'll change the B2 cross section. So I can use the drop-down menu and reuse the cross section I selected before. So now you can see that this connection that was created is adjusted just because I changed the size of the cross section. And then you have, when you click over the members, you can always modify its angles, its inclination. Like in this case, I'll use a pitch angle of -5, and then the same for B2, okay? So -5 there. Again, this is adjusted here, right? And the connection is already modeled here, so we'll go through that operation that was used to create this plate-to-plate connection, okay? So that's how it's called, plate-to-plate operation. And then if you go into new operation, you can see that's this operation. That's the one that was modeled in that template, all right? Then let's modify the material. The material is ANN2. As I said, that was the default, but you can come here and change that, okay? And then you can see that this is bolted, but as Colten mentioned, he just wants to have welded connection, so you can change the connection type here to welded, right? So now there is no bolt. Then you can see that for the haunches on this model, another type of, well, widener operation was used, right? Widener number 2 was related to the second plate just because it was a bolted connection, right? So I'm just going to turn off this operation here. All right, let's go back to plate-to-plate operation. Now I'll set up the dimensions of the top offset, left, bottom, and right offset from this operation. So that'll be 5/16, and then the bottom part will be 6 inches here. If you see, this plate will be flush to the member, so left and right is 0. Okay. Then we can change the weld type for the flanges and web, right? And that's where for instance, in this case, will be very useful for Colten to have PGP. At that moment, I believe that was around April. We hadn't had that PGP option, but now we have that. If you select the partial joint penetration, but well, now you need to input the effective throw thickness. If you're using fillet weld, then you input the leg size, all right? So you can always hover the mouse and see what value you're inputting there, okay? The representation of the PGP, don't worry about that. I mean, if you're looking at this side, don't worry, it's just the graphical representation. At the end of the day, what is important is effective throw thickness and that we have a link from this plate to this other plate, right? If you see the transparent view, you can see that line internally there. So that confirms that we are creating a weld, okay? So let me go back here and change the webs to 1/4, and I'll keep fillet weld for both of them. And you can type here the size of the weld. Now, in this case, if you look at the within our operation, I mean, in the project detail, we have a cross section. And Colten, if you can explain here, like they had, the client had these portions of W sections to create those hunches, right? That's why you use an actual cross section, isn't it?
Yeah, they wanted to just reuse some, I think, common materials that they had in their shop.
Yeah, perfect. Yeah, so I mean, you always have the option to use the winner operation, and you can see that this is a triangular shape with a flange, right? That is almost similar to having a Y flange. But if you want to actually use the cross section that, for instance, in this case, the client had, right, and he wanted to reuse, then we can use the stiffening member operation. The stiffening member operation will help you to add a cross section into the connection or into this model as part of the connection, right? And it's not a member, an actual member. So you don't need to add forces, and then you can set up the length of that member, all right? It is not like attached to the joint or to the node. All right, so for that, what I'm going to do here is I am going to select 8x13 cross section. So if you saw, we have the same menu to select whatever cross section to add in that stiffening member. So I click OK here in NN2. And then in this case, I am using the origin as the joint. So I can use the coordinates here. So you can see that's added from the node, but you can always use these coordinates here. So I'll use minus 0.75 in the C direction. And then I'm going to use this pitch angle to be 19.4, all right? So to attach this or to create this stiffener, I'm going to increase the length of this side to 1 foot 3 inches, right? So it can pass through the plate to this bottom flange plate. So then later I use a cut operation, okay? So for that, I'll go and hit new operation and then use cut off member operation. Now I'm going to cut SM1, so that is a member, and that will be cut by B1 bottom flange first, okay? So that is B bottom flange 1, but I am cutting the beginning of the member, so I'll select end, so that cuts the other part, right? Now we have this extra portion here, so I'll reuse this operation, this cut operation. So now I am cutting SM1, sorry, by the plate. So this is plate PP1, so I select a plate, and that's it. So then I change the part that I want to cut there. So now we have the welds from that cut operation, all right, and the cut, okay? So now if I click over this, you can see that you can change the type of weld and then the sizes, okay? So this is also where you probably will need to use a PGP weld. So you can select that. Again, you can see that PGP representation there, okay? Let me see here. I think in this case, he used butt weld or CGP weld and then double fillet weld and change this to 1/4. All right. So those are the options for the weld. Then for the other side, then we use the same SM1 operation. So I'll copy this SM1, and I'm just going to add a negative value to the pitch angle for that new SM2, right? So now it's in the other direction, and I'm going to invert the length 1 and length 2 here. So that will be 4 and then 1, 3, all right? And reuse the cut operations from here. Remember that you can always copy operations and then change the reference here. So that will be B2 bottom flange 1, and that will be the begin now. And I copy that, and that will be SM2 by a plate, PP1, and then I change what part of the member you want to cut. Okay. So that's it in terms of modeling this connection. Well, sorry, I'm missing the openings to represent, you know, the rods passing through those two web of the beams. All right. So to add openings to members, you can use this opening operation. Okay. So that opening operation is set in one of the plates of the members. Okay, so in this case is B1, web 1, and then you can select different shapes. So in this case it was a circle, but you have more options in this operation. I'll use 1.5, and then the position is from the starting point of that member. Okay, so that will be 10 inches. And then here we have an eccentricity. So that will be from the center line of that B1 member. So I'll use -5 to put it in the top side. Then I just copy this operation, right click, copy, and now I select B2 web 1. All right, there you go. So now let's jump into the load effects. You can see that I selected LRFD, so I can go back to the name of this connection and change it to ASD. All right. So what will be the difference? Well, we use the factors for ASD, so now we divide the resistance by the factor of ASD, right? And the load effects that you input here are from ASD combinations, okay? So make sure you don't confuse yourself with that. If you use LRFD, what we are doing is that we are multiplying the resistance by 0.9, okay? Or, well, depending on the factor that you're, if it's for bolts, for welds, or for the material, okay? All right, so now let's change the forces. So this one has 105 moment in both beams, no shear force, and then I'm just adding an axial force of -12 kips, right? So I am adding the moments and the axial force on both beams, okay? So I think we're ready to go. So we calculate this. So let's calculate. And if you're new to the software, you're always going to see summary over here, and then like a traffic light system, let's say, in the material or in the plates. So the green color means this is between 60 and 95% of utilization, right? So to really review the results, you can go into the check tab here, and you can activate the form shape. So that is your first your first way to see if this is behaving as you were expecting, right? To activate this deformed shape, you need to activate the equivalent stress contour plot, right? And then you can see that this is now it is available to select. Now you can see the deformed shape and the stress contour plot, all right? So the maximum, let's say, scale that we have here is 29.9 kCi, right? That's because we use ASD again. Then if you go into the plates area, and then you can see all the plates listed here, their maximum stresses and the plastic strain, if that happened in this model, right? And then you can click over the plus icon, and you will see what were the design values used in this analysis, because we are using, again, ASD. Now, this value, the maximum elastic stress that can be, let's say, used is 29, right? Because we are dividing 50 divided by 167. That's the safety factor for AISC, for ASD methodology. And if we go into the welds area, you can see the utilization ratio here, all right? So you can order the utilization ratio for each of the welds that you have in this model. We also convert those welds into shell elements. So you can see here if I activate the mesh, right? And if you click over the different like welds items in this list, you will see the equivalent stresses along that weld, okay? So let me decrease the size of this so you can see the different plots that we have over there. So the advantage of using, as Colten mentioned it, like using this FEA view or FEA methodology in connections is that you can see the stresses and the hotspots, right? Like in this case, we don't have stiffeners, but in the moment frame connection, you can see how is the stress flow and how you can improve that or decrease the hotspots on the model, right? And also you can see, for instance, this is very useful to look at the stresses around that opening. If you were to have a larger opening here, one interesting thing that we have for that opening operation is that we have this stiffener option. So that will add like a stiffener in this opening, and then you can change the weld for that stiffener, right? And it's creating like a whole section as stiffener of that opening. All right. So that was the starting from scratch demonstration for this connection. Let me go back to my presentation here, okay, and show you what we use or the key operations we use for this. So we use the plate-to-plate that can be bolted or welded, right? You can see that, well, in the presentation you saw that we use the stiffening member to create a hunch, but you also have the option to use a widener, okay? We represent the openings, we represent the tension rods with an opening, okay? And in this case, something that Colten mentioned about this project is that he used the section drawings to send details to their detailer to create the drawings. That's something I didn't mention on the screen here, but you can always create those section views by right-clicking and create this section from here. So if you see that we have many things happening on this drawing, okay, you can always increase this view here. And we have now the option to turn off these different values. Like if you just want to see the welds, and well, in this case, we don't have openings, sorry, the bolts, but you just say, okay, I just want to show the welds details there, okay? And then when you create the report, this picture will be on that report, okay? All right, let me go back to my presentation here. All right, and here I have some details about the plate-to-plate operation. We'll share this slides in the main website where you register for this webinar, so you can see more details about these operations. But the best is to go to the software and start testing all these operations that I use and that I explain today. All right. Now let's jump into the second moment frame connection. I'm highlighting this particular case or this particular connection here. And that's the one I'll show you today. So if we do assume here, we can see that this is like the main moment frame. And then here we have the moment beam, and that's connected to a smaller beam. Colten, if you can explain us a little bit this detail here, and then later I'll explain how we model that portion.
Yeah, so they wanted us to maximize that mainframe beam span just so we could reduce the member size, that W10 by 22 on the back end, just by cutting its span down. And that was the only condition where we had this, so it was kind of a one-off thing, but we were pretty, yeah. We had the mainframe already modeled, so it was pretty easy to just modify that and get some new numbers out of that. So yeah, it was just economy, really, is more than anything.
All right, perfect. And then you had the X braces connected to the web of that beam, right? That was also one of the.
Yeah, that was the one where we kind of played around with what what does it look like to put this in IDEA StatiCa and put some tension on it? And I know you're going to get into that part of it, but that was a unique learning opportunity and experience for sure.
Yeah. That was interesting. That's I like to see different types of connections, and I learned a lot. Yeah. So for that detail, well, Colten explained that he was joining that tensor to the web of the beam, and then for that he had this detail of hillside washer, and that hillside washer, it's this small plate, right, where they pass the rod through the plate. So this is like the web of the beam, and then they attach it to this washer. Right. So we wanted to represent this to have the tension on the web of the beam and see what will be happening to that web or to that plate, let's say. And let me explain you how we did that. Before jumping to the model, I just have 2 slides here on how you can model rod elements or tension cables or tension bracing in IDEA StatiCa. The first option, and the most obvious, is to use the rod cross section, right? That is under our cross section navigator. That's this option here. And yes, it says this slide, the rod cross section is dedicated mostly to tension elements. That member is modeled as just 1D element. We don't like make a shell element of that member. Okay, it's just like 1D element in the FEA analysis. It's always recommended to use MBYBC because that won't handle any moment, right? And that will be used as a bracing. However, one of the drawbacks of using this shape is that it can be only used with connecting plate operation and gusset plate operation. So you can see these are the 2 operations where you can use that rod member. You cannot use cut, you cannot, many of the operations cannot be used. So you can see here the 2 examples. This is a connecting plate, and this is a gusset plate operation, right? So that's the only situation or the only way to use them. Okay. The workaround for most of the cases is to use a hollow section, but like a custom hollow section, where you input the diameter and the thickness. So you model it a really thick hollow section to represent that rod. By using this option, you can then use all the operations we have for regular cross sections. All right. It's also important that you use model type MBYBC, and that's how you can assess that. One option at the start when we were discussing this model is just to cut that hollow section. That's how we use this. I mean, that's how we model the bracing in the Colten's model. At the start, we were like, okay, let's just weld or connect that rod section by a weld to the web of the beam. However, if we look at the detail of the hillside washer, this is not connected directly to the web, right? The stress is coming from, the contact between these 2 plates here. Okay, so let me show you how we approach that, and also I'll show you how we extend this member here from the node to have the 2 connections, like the moment connection, the actual moment connection, and then the shear connection coming from the smaller beam to this other moment beam. Okay. So let's jump into the software again, and let me bring that model to the screen. Okay, so let's talk first about how we set up the geometry. Okay, when I am talking with users, I always recommend to have the bearing member, that in this case is that is the column, at the same position of the node. So that means we are not moving the column, or we are not offsetting the column from the node, right? You need to move everything around. So if you see, we move this rod element that's representing one of the tension bracings, right? Here you can see that we use an offset EY, okay? And this is at the node position. Why is at the node? Because there is 0 offsets over here, okay? So I can show you here as well. And then for this member that we want to extend it like 4 or 5 feet from the node, instead of using the offset EX, that will be the most obvious thing to do. It's just better to use operations. I am always talking about not using the offset EX, because what you're doing with the offset EX is that you're moving the starting point of the member, okay? So the best approach is to use a working plane operation. The working plane operation helps you to cut a member by that working plane, okay? So this working plane can be set up from the joint, then you use this coordinate to move out that working plane. You can also add rotations. And then later in a cut operation, you use that as a reference. So I cut that beam B, call it beam B, by working plane 1, right? So that's how I extend that member. Then this member is still here, right? It's attached to the node, or it's starting from the node. So now we use a cut operation to cut that member by that working plane that we create. So now the member is where we want it, and then we just need to model the shear connection over here, okay? I'll use the operations that are here, just activating them. So again, for the hinge portion in this area, we use a stiffening member operation. Then we use cuts, right? Similar to what I did with the first connection, then the stiffeners. And then for the shear connection from this member M3 to B, we use a splice plate. We turn off the bolts there, all right? So this splice plate operation just helped me to add the plates there and related to these 2 members, because that is related to B web 1 and M3 web, right? So that helps me to just locate the plate, and then later, instead of the bolts, we use a weld operation. So we can add a weld operation from this splice plate 1 to B web 1. Then I activate the second, so now that is that welder. And then here we have another weld operation, another 2 for these 2 sides, all right? So that's the shear connection. Now, if we look at the now let's start looking at the detail with the rod elements. So for that, for the hillside washer, the workaround was to simulate that hillside washer with a plate. That plate was modeled as a doubler of this web of the beam, right? And then we use a cut operation to cut this rod member, well, that tension brace member by this plate. So if we activate that and see the transparent view, you can see that now that rod is cut by this SP1. How I can see that? Because we have here the weld, right? But now that is passing through the web, right? That's why we have this clash warning here, okay? So what I did here is cutting the member B by M4. M4 is that tension rod. Okay, so I activate that, and we use an offset. So you can see, let me rotate a little bit this web of the beam, so that's member B, it's cut by M4 as with a surface methodology and an offset of 1/4. So see how this is cutting that member here, right? So we ensure that there is any contact between this member and the beam member, okay? Everything is going to come from the tension force, then the connection to this plate, right? But that plate is not connected to the beam B, right? Not yet. So for that, we added a weld operation, okay? So that's this weld, because we need to connect this plate to the system at some point, okay? And finally, we needed to add a contact operation from this plate to this other plate. Contacts are created automatically when you have a bolt operation. But if you don't have a bolt operation, like in this case, you just have a weld to connect this plate to this other plate, there is no contact, all right? The only connection is by using this weld, okay? So for that, you can use a contact operation, okay? And that contact operation will add that, you can see that like red hash, or that red portion here that is representing the contact from SP1 to BWeb1, okay? So that contact is added with this operation here. This is the grid contact operation. Then instead of selecting an anchor or a bolt, you select contact, okay? So now the force is coming from tension force here from this member, then caught by that other plate. We have a weld connecting that rod, and then how we connect this plate to the other with a weld and a contact, right? So that's how we represented that hillside washer. So let me show you the final model here. There was also another member here that was joined using this stiffener, all right? So you can see that we use stiffener operations, cuts, and also Colten used lateral torsional restraint. So we represent the restraint at the top flange of these two beams, okay? And yeah, so that's how we represent that. And then if we look at the results here, again, we can look at the equivalent stresses, and here we can look at the stresses on the web of that beam and ensure we are okay with those tension forces on the web of the beam, and represent this the most realistic way. All right. So yeah, let me go through the final slides, so then we can jump into the Q&A, right? So again, modeling key operations: working plane to extend members, stiffening members to create a hunch, rod bracing only tension, we use hollow sections instead of a rod, and then the hillside washer was represented with a plate and some cuts, and contact operations. Contact operations are available for plates, and then you can model surface to surface contact, edge to edge, and edge to surface. All right. So that's the summary of that second connection. Jan, do we have some questions?
Yeah, we do have just a few actually. There's been actually a few questions about the recording. So just to reiterate, that recording will be made available on our website and on YouTube within just a few days, I guess, maybe by tomorrow, depending on when Andrea can get to it, to be honest. Then a question, a follow-up question to what Colten was saying at the very beginning in the introduction. Colten, if you can give a bit more information about what you were expecting in terms of saving, or what you received in terms of saving by using IDEA StatiCa. So you said it's not so much about time saving, but more maybe about material saving, about optimization, and also about making sure that you can do what your client asked you to design. Is that right?
Yeah, I think I may have not worded that well, but having a software, I think the benefit of something like this is to be able to go outside of the bounds of what's been tested, but do that safely and still meet code requirements for the way in which you're going about that. And so that would be one side of it that I was trying to highlight. And then the other side being rapid iteration on things pretty quickly, and changes can be made, especially once you understand the software. There's with any software, there's a lead time in understanding how it functions. And one of my favorite quips is, you got to know how to break the software, and how to make sure that you understand where you can go wrong. And so just that idea of putting the time in up front to understand how it's thinking and how it's doing things compared to code, standards, mechanics of materials, all of the basics. And then once you get that, down and you feel comfortable with that, applying that to every project. I hope I answered that. I clarified maybe a little bit.
Yep, no, that's correct. Perfect. Question actually for you, Andrea. Can you just show how you switch from LRFD to ASD? And I think if you want to also touch a couple words about how to change the mode of analysis, that could be useful.
Yeah. So whenever you are here in the main connection, you can go to the title, like the main title in this list of items, and then that's where you can change the design code edition, let's say. So that's ASD or LRFD, depending on the year that you want to use. Also, from here, you change the 2 different analysis types.
Perfect. Can you explain a bit more what the torsional restraint operation does?
Yeah, so the lateral torsional restraint, well, you can decide if one of the plates will have either lateral or torsional restraint. You can say torsional, it's going to be free, rigid, or you can set a stiffness there. Also, the lateral restraint, in this case, Colten set up a stiffness for that lateral restraint, and that was set up to this plate here. And this is to mainly represent the pore length at the top flange. So that let's say that plate is restrained against that lateral rotation or torsional rotation, right?
Perfect. There's a question, I'm not fully sure I understand it properly, but how did you get to this final connection type, Colten? Were you asked to have, for example, all these, like that exact geometry, or did you end up having to place the stiffeners that way, some of the elements like this because of the loads? How did you get to that final result?
Yeah, I'm guessing specifically the question might be asking about the pipe and then the tapered there on the column.
Correct, probably.
Yeah, so that was a geometry, more of a fit up item. And so getting it tapered and putting that pipe right there, that was the reason we did that specifically. And the client, they kind of knew they had some previous projects in the way that they wanted to do it. And so we were doing a bit of both, of trying to meet what they were good at and how they did things versus what the loads and the analysis was saying for the design.
Perfect. So far, that's all I have for questions. There's some very long questions. I think, we'll have to take some time to read them.
Up. Yeah,
exactly. Yeah,
we can follow up later. Yeah, and just the final slide that we have here is about the upcoming events, the in-person events and webinars coming. So yeah, feel free to reach out if you have any question about this.
And I'd just like to jump in at the end here and just thank Colten for his help with and kind of presenting this with us. We definitely appreciate that. And I would say, if any of the attendees out there have fun projects that they would like to kind of show off to the rest of the users and structural engineers, feel free to reach out to us, and we can try to get you on the schedule. Otherwise, we're just about 1 o'clock. So thanks again for attending, and let us know if we can be of any assistance. Thank you. Have a good day.
Thank you. Bye.
Yes.